Alexander Fitzjohn, dissertation poster.
Over the past 50 years, the African hunting dog, formerly known as Lycaon pictus, has been subject to a number of different factors that have left it being one of the most critically endangered carnivores in Africa. Due to the loss of habitat from human expansion, the introduction of diseases such as canine dysentery and rabies, as well as human-induced mortality, it is estimated that there are fewer than 6,000 individuals left in the world. They can weigh anywhere between 15 to 25 kilograms, and their pack sizes can reach up to 40 members. They are one of the most officious hunters on the planet, with their key to success being their social organization and cooperative behavior in hunting. This means they can take down prey much larger than themselves, and they have much higher foraging rates than they would do if they hunted alone. There is very little known about the wild dog's movement in relation to both vegetation cover as well as hydrology, and my dissertation will focus on 4 separate packs, having collected data for one of them myself. I will attempt to answer 3 key questions. Firstly, are African hunting dog movement patterns influenced by vegetation cover? Secondly, are African hunting dog movement patterns influenced by hydrology? And lastly, will this help monitor and predict the movement of various packs in the near future to ensure their safety and conservation? Right, now onto the methodology. Over the summer, I was present for the translocation and release of a pack of 12 wild dogs in Mkomazi National Park, Tanzania, seen in Figure 1. This program breeds these dogs and releases them back into the wild in an attempt to combat the threatening numbers that their species face. They were sedated by a vet in the location where they were raised and driven to the release site 2 days before the release date, as can be seen in figures 4 and 5. The alpha female was sedated and a VHF GPS transmitter collar was added to her neck. The GPS gave 2 exact readings every 24 hours, whereas the VHF collar remained constantly transmitting. This was to ensure the safety of the pack, to be able to monitor their movements and ensure that they didn't venture into any rural populations. However, this also meant that I had real-time access to the location. Tanzania National Park authorities chose the collars as it was readily available in the country at the time, and it had the capacity to transmit both GPS and VHF signals. The collar was also designed by the manufacturer Telonix to fall off after 8 to 12 months of use, to ensure that once the batteries had died, it wouldn't be a nuisance to the dog any longer. The GPS transmitter was needed as the location of their release site was located on an international boundary between Tanzania and Kenya, meaning that once they had ventured far enough into Kenya, the VHF transmitter would lose the signal. Unfortunately, after 5 weeks of being released, the alpha female was poisoned in Tsavo National Park by illegal livestock grazers. The collar was then smashed, meaning that the pack could no longer be tracked. I therefore had to source data from elsewhere, namely the Botswana Predator Conservation Trust. I was able to get the GPS data for 3 separate packs that were studied and released, with data spanning for up to a year. The GPS coordinates for the initial pack investigated can be seen in Figure 6. This data, along with those for the other 3 packs from Botswana, will be overlaid onto an NDVI vegetation cover image, as seen in Figure 8. This is downloaded from the USGS Glover satellite, and this will be done using QGIS. After completing all the mapping required, I'll have the data and maps showing the movement of 4 separate wild dog packs spanning 4 different countries in Africa. This data should be enough to reliably determine their movement in relation to hydrology and whether the pack animal prefers areas of high vegetation or low. It is expected that the wild dogs will prefer spending time in areas of high vegetation or green vegetation. This is due to the fact that firstly, the majority of their prey will spend the majority of their time sheltered in the bush, as opposed to being out in the open. Secondly, these areas do provide shade and shelter from their respective environments. And lastly, during the heat of the day, from around 11:30 to 4 p.m, predators will rest in the shade and very little hunting will commence during this time. Furthermore, studies in Kruger National Park in 1993 by Stander and Albon have shown that 65% of the dogs studied preferred closed woodland as opposed to open woodland, with 65% preferring the closed areas and 35% preferring the latter. There are many other factors that could not be investigated that affect wild dog behavior and movement other than vegetation and hydrology. Wild dogs are often found in areas of low carnivore density, mainly, and will avoid areas where large carnivores such as spotted hyena and lion are present. A lion will deter the majority of the packs, even if that area is prey-rich, as in some areas they account for a large amount of wild dog mortality if they come into contact. In the Kruger National Park, for example, lion were responsible for 43% of natural deaths and 39% of natural pup deaths. So what's left? The only thing to do now is to overlay the GPS coordinates for all 4 packs onto NDVI and topographic images downloaded from NASA satellites, such as GLOVUS, MODIS, and Earth Explorer. Thank you very much.